towards maths and stats.
Mathematics. Yeah.
Maths and stats both.
Yeah. So yeah, we are live now. So we will discuss these things later. Okay.
Okay, sir. Okay,
Is my
sir.
screen visible?
Yes, sir.
Right. So okay. So I will just give you a gist of what we are going to do for the next 2 hours. So we will start with F test. So for that we will start with understanding what is F distribution, and then we will see when can this F test is applicable at for which situation, and then we will quickly recap. So whatever we did in the last 2 sessions, we will quickly recap. So which test is applied to at which situation. So when you see the particular question, so which test you have to use. So whether it is G test or right now you have seen till now you have seen Z test, T test, so which is also called a student T test, and then there is chi-square test. So you have till now you have seen 3 tests, and this is the 4th test we are going to do, which is called F test, where we use the F distribution as the PDF. So what is this F distribution? So F distribution has 2 parameters. One parameter is n1 minus 1 and another parameter is n2 minus 1. So this n1 and n2 comes from 2 different samples. So this is how the setting will be. So if you have 2 different distributions, one distribution you say it follows normal with mean mu1 and variance sigma 1 square. So this is one distribution, and another distribution that follows normal with mean mu2 and variance sigma 2 square. So 2 different distributions, and from 2 different distributions, from the first distribution we take n1 samples, and from the second distribution we take n2 samples. So these are the samplings we have taken from 2 different distributions. Okay, and also these 2 are independent to each other. Okay, this is one more condition. So what we did till now is we have 2 different distributions. Both follows normal but with different mean and different variances. From one distribution we have taken n1 samples. So you can see x1, x2 to xn1 are n1 samples, and from the other distribution we have taken n2 samples. Okay, this is what we did till now. So let us consider the first distribution and this n1 samples. So what will be the sample mean be? So what is the sample mean?
Sigma 1 square by n.
Mu. So what is the sample mean x bar?
So
x1 plus x1 plus x2 plus
yeah.
x1 divided by n.
And so on x
N.
n1
N1.
divided by n1. So if these samples follow normal mu1 comma sigma 1 square, then what will this sample mean follow? Which distribution this particular sample mean follows?
Normal.
The normal only, sir.
Normal.
With
mu1.
mean mu1, correct?
1 square by n.
Sigma square upon n1.
Yes.
n1.
Correct. So similarly, tell me what will this y bar, which is the sample mean of the second samples. So these n2 samples. This will follow normal mu2 sigma 2 square by n2. Correct? Correct, wrong, still confused with how
No.
this particular
Yes, sir.
thing
Correct.
works.
Correct.
Right? We have seen these things from past 3 weeks, I guess.
Yes.
So we are seeing these things. Okay. Now we know this particular distribution and this particular distribution. What will be the x bar minus y bar distribution?
Normal.
Is normal.
mu1 minus mu2.
Correct. Mu1 minus mu2. And what will be the variance?
Sigma 1 square by n1 plus sigma 2 square by n2.
Sigma 1 square by n1 plus sigma 2 square by n2.
n2.
So what will you do if you don't know this? What is the standard approach to find this? So don't forget the basics. Always that will help you. So take this x bar minus y bar as some new random variable z. So what is the expectation of z? It will be expectation of x bar minus expectation of y bar. So expectation of x bar is mu1 minus mu2. So this is the expectation or mean for this new random variable x bar minus y bar. So this mu1 minus mu2 will be the mean. And what is the variance of z?
Variance of x1
Variance of x bar
Plus
so
minus 1
plus
square.
minus 1
variance
whole
of
square.
minus y bar. Correct?
Yes.
So you write it like x bar plus minus y bar as one thing. Now what happens? Minus 1 is the constant. If I bring that out, it will be minus 1 square.
Yes, sir.
Yes. Yeah.
Correct? So this is like variance of x bar plus variance of y bar. So minus 1 ka whole square is actually 1. So it doesn't play any role. So this variance plus this variance will be the variance of z, the new random variable x bar minus y bar. So this variance plus this variance is the new variance. Okay. So if you forget whether it is mu1 plus mu2 or mu1 minus mu2 or sigma 1 square by n1 minus, so what sign it will be plus or minus? If you are confused with that, so go with basics. So how to compute expectation of a new random variable when you know it is actually a sum or the sub difference of well-known random variables. Okay. So this is, so if it is x bar and y bar for mean, sample mean and sample means difference, we know this follows normal mu1 minus mu2 by sigma 1 square by n1 plus sigma 2 square by n2. Let's also look at the sample variances. So we have the samples with us. So if I wanted to compute the sample variance of the first sample, first n1 samples, this is what the formula is: 1 by n1 minus 1 summation I is equals to 1 to n1 xi minus x bar whole square. This is what the sample variance of these samples x1, x2 to xn1.
Yes, sir.
Correct?
Yes, sir.
Yeah. Similarly, the sample variance of the second samples. So next distribution sample, there are n2 samples, and if I wanted to compute the sample variance of this particular y1, y2 to yn2, this is what it will be: 1 by n2 minus 1 summation from I is equals to 1 to n2 yi minus y bar whole square. This is what the sample variance formula is. Correct? So here I have n1 samples, here I have n2 samples. So n will be n1 at one place, n2 at another place. That's it. Okay.
Yep.
Now tell me, this we know. This we know from week 7. This is the new thing we learned in week 12. So if this particular sample variance if you have, then n1 minus 1 multiplied by sx square divided by the population standard, the population variance, this will follow something.
Chi-square distribution.
So this will follow chi-square
N minus 1.
n1 minus 1.
Yeah.
So here n1 samples are there. So how many of you know this before?
Yeah.
Like if you have the sample variance with you, then n1 minus 1 divided by sigma 1 square times sx square will follow chi-square n minus 1 distribution. So this is what chi-square test is about, right? So when you are testing for sample variance, so when you are testing for variance, then how do we compute alpha? So we'll compute alpha by converting this particular test statistic into well-known chi-square distribution. So how do we convert that? We just multiply n1 minus 1 divided by sigma 1 square to the sample variance. Then this particular new thing will follow chi-square n1 minus 1 distribution. So from there we know the probabilities of this distribution. So we will compute alpha, beta, and everything. Okay. Similarly, what this will follow? This will follow chi-square
N2 minus 1.
n2 minus 1. Now till
Sir,
here.
this degrees of freedom required to be extended. So we didn't understand the degrees of freedom. N minus 1.
Oh. So okay, this is not a big thing. So this is degrees of freedom, right? So actually, what degrees of freedom is actually is how many number of variables can vary, matlab independent to them and then can vary. So how many random variables can take any value without depending on other. So how many are there in this x1 to maybe
N, N1, sir.
n1? Is it n1? Just think about a minute. Okay. So see, first and foremost thing is, in order to compute sample variance, we need to know sample mean. This everyone agree? Matlab, you should know sample mean in order to compute sample variance.
Yes, sir.
Yes.
Yes, sir.
Yes.
Yes, sir.
Correct. Now what exactly sample variance is? So if I have some samples x1, x2 till xn, what is the sample variance? It is actually 1 by n minus 1 times I is equals to 1 to n xi
minus sample
maybe
area,
sample
the whole
mean.
square.
X bar
Yeah.
whole square. Yeah.
So this x bar is known to us.
Yes.
So if you know x bar, what it is actually, if you know this thing, x1 to xn summation divided by n is nothing but x bar. Correct?
Yes, sir.
Known and fixed. Okay. Now you see x1 minus x bar whole square plus x2 minus x bar whole square and so on plus xn minus x bar whole square divided by n minus 1. This is what it is. Now once you know x bar, that means you know the sum of all the random variables, you know, that is fixed, which is n times x bar. N times x bar is nothing but x1 plus xn.
Yeah.
Try to understand this. And this is fixed. Matlab, this is something like mu or something else, some mu naught. So sample mean. So this is fixed and this is fixed value. And how many random variables can vary without depending on any other things?
N minus 1. Nee, N, no, sir.
See, if you
N minus 1. N minus 1.
Nee, why N minus 1 basically? Acha, compared to the other one, compared to one single. Okay.
Okay, let us take
X1.
x1 and x2 only. There are two samples only. Okay. Two samples. What is the expected value of x? Or sorry, what is x bar?
1 plus x2 by 2.
x1 plus x2 by 2.
Right. Mm-hmm.
Okay. Now if I wanted to compute s square, okay, so what it will be? x1 minus x bar whole square
Yes.
plus x2 minus x bar whole square by 2. Correct? I know
Yeah.
I can write x1 as 2 times x bar minus x2.
Okay. Got it.
Yes,
Okay.
sir.
Oh, okay.
So basically, you can write it as a linear combination of the remaining.
Correct.
Okay.
So if you know
Got
the
it.
linear combination things, how many are independent to each other? The xnth term is actually dependent on the n minus 1 terms. So whatever the n minus 1 values it takes, so it will sum it, everything will be summed, and you twice it, or sorry, you multiply it by, okay. So xn, you can write it as, it is actually n times mu naught minus x1 minus x2 and so on minus xn minus 1. So these many n minus 1 random variables can vary. Whatever the value it can take, but xn will be fixed. It will be like n times mu naught minus whatever the sum of other n minus 1 random variables is. Though xn is not a free variable.
Right. Okay, I got
Okay.
it now. Yeah.
So that is why.
So, sorry to interrupt, but would you go over the last couple of things?
I
a
didn't
little
understand
more
last
time?
thing.
Yeah,
What
please.
you have said, sir.
It was
Okay.
still about xn, x bar. When you are saying it is the average of all the n, that is okay. But okay, you put it as x bar is equal to x1 plus x2 by 2.
Mm-hmm.
And you're calling x1 as 2x bar minus x2. Now, in case of multiple variables, how does it translate is what I was just trying to understand.
Calculate for 3 and 4, sir.
So it will be 1, right? S square.
For this, the number degrees of freedom is 1. This
No,
understood
divide by
about,
1, sir.
correct.
Okay.
Have you understood? Everyone understood this two samples case?
Yes, sir.
No.
sir.
Can you repeat this?
No,
Please?
sir.
Can you repeat this?
Okay.
Can you repeat?
The first and foremost thing you should understand is, in order to compute sample variance, we need to know the sample mean, right?
Yep.
Yes.
Sample mean, if you know, x bar if you know, then only I can compute this sample variance.
Yes.
Right?
Yeah.
True.
Now we know, what we said is, we know the sample mean. So this is fixed.
Mhm.
This is constant. X bar is constant. Okay. And x bar is actually the sum of the two random variables divided by 2. So that is what sample mean is.
Yeah.
And as this is fixed, you take it like some k, some value k.
Mhm.
So I can write x1 as 2k minus x2.
Yeah.
Right.
Okay.
Now if I can write x1 as combination of in terms of x2, so I just substitute here how many s square is dependent on how many random variables, or you simply see
It's only on x2. Okay, that is also understood.
so
X2.
you can simply see how many out of these two random variables, how many random variables can take freely, like whatever the value it can take. How many random variables are
1. Only 1.
Only one is
freely yeah, correct. So if x2 you can vary, if you are varying x2, then x1 is
X1
dependent
is
on
varying.
x2. Okay, x1 cannot take any other so it doesn't have the freedom. Okay, so this is what
Sorry, what, sir?
Hello.
What you said last line?
So what am I saying is, so x2 has the freedom to vary.
Okay.
Okay, value of x2 can vary from maybe the range, throughout the range or the support. X2 can vary. Okay, x2
Yes.
has that freedom, but x1 doesn't have that freedom. X1 is dependent on x2. Whatever the value x2 takes, you subtract that value from 2k.
Okay.
Okay, x1 is now dependent on x2. It's not free variable.
True.
Okay, out of these two random variables, if I have two random variables, if I am considering for sample variance, for the sample variance, only one random variable can freely take.
True.
So it has freedom. Only one random variable has freedom.
Degree of freedom 1. Okay.
So the degree of freedom for two random variables is
1.
for sample variance is 1.
So likewise for n random variables. It
For
will
n
be
random variables case, what
1.
happens is, so your sample mean is fixed.
True.
So when what is sample mean? X bar is equals to
X
x1 plus
bar.
x2 to xn divided by n.
Yeah.
So if I say x bar is something mu naught, then what will be the sum? Sum will be n times mu naught. So you just bring this n to the right hand side. So this is how it
Okay.
I have a question here. Okay, this arithmetic, I would call it arithmetic. Just please bear with me for if the use of word is wrong. This arithmetic significance is okay, but I still need to know x bar prior, isn't it? So even if it is a constant, I'm starting with x bar. What is the advantage here?
You are starting with
I'm starting with knowing X bar and X1 in the computation for standard deviation or variance.
we don't know x1.
I don't know X1, but I know X bar. That means I already
You know
know
x bar.
X bar and X2 means like I already know what X1 is. But the
No,
same.
we don't know what x1 is. We only know the mean, sample mean.
Oh yeah. Okay.
See, in this particular thing, x1 is
Uh-huh.
random variable, but x bar is a fixed value.
Yeah.
It's not a random variable.
Okay.
Okay. So if
Okay.
this is fixed and constant value, then that means you know the sample mean.
Yes.
Yeah.
Okay.
Okay.
So if you know the sample mean, so you know the sample mean, but you don't know what random variables, what are those n random variables, but you know the sum of random variables divided by n ka value.
Yeah.
Okay, that you know. So from there, what we are deriving is how many random variables out of these n random variables, how many random variables have freedom to vary. So
Okay.
so they can vary freely.
Yes, they can take any value.
They can take any value in the support. So there will be only n minus 1
Degrees of
such random variables,
Mhm,
and the
mhm,
nth random variable will always be dependent on this n minus 1 random variables because x bar is fixed. So for
Yeah.
sample variance, x bar is fixed. Okay.
So it's no longer a random variable that we
It's
start
no
off.
longer a random variable.
Okay. Okay.
Okay.
True.
So from there we will get. So you see in general also you see this t distribution or the chi-square distribution. These all are we will use for sample variances. So whenever there is a sample variance comes into the picture, so the degrees of freedom will convert to from n to n minus 1. So one random variable will be actually dependent on other n minus 1 random variables. It will convert like that.
Okay. Okay.
Okay. So you can see in the student t distribution, actually we replace sigma with s, right? S comes into the picture.
Yes.
Yes.
Yes,
When
sir.
s comes into the picture, so what happens is that particular z, whatever the normal, will convert to t distribution.
T distribution. Yeah.
Okay. So and also the number of degrees of freedom will be one less than the total number of samples you have. So
N
something like
minus
t n minus 1. It follows t n minus 1.
Sir, will it be n also sometimes? Like just now you said that, in case of sample, it will be n minus 1. So will it be n also sometime?
See, whenever you are looking at random x bar, so if you don't know x bar, then all these n random variables are free to vary.
Yes, we have to calculate that at that
Yeah.
time.
So no need of much stress about this degrees of freedom. Just
Okay. No.
how
No,
many?
that statement brought a doubt.
So degrees of freedom is nothing but the number of
variables which are free.
Random variables
Which are free to take.
which can vary freely. Okay, this is what the degrees of freedom is.
Yes.
Okay.
Sir?
Yes.
Like here we are dividing by n minus 1 and we are understanding it through degree of freedom concept, right?
That is one more.
But in weak things, I think you had done a very good mathematical derivation and you had proved that why we are dividing it by n minus
that is
1.
different thing. Yeah, that is also one thing. See, this is one more reason why we divided by n minus 1.
So the same concept can be explained
yeah.
two ways, right?
Yeah.
Okay, sir. Thank you for highlighting both the ways.
What is the other concept? Please just mention a word again.
Mathematical derivation he had done
That
in
is in week 6 or some live session.
Week 6 or week 7 he had done mathematics.
I just gave you about this why we divided by n minus
by
1.
n minus 1. Okay. Okay. Okay.
So yeah, according to this degrees of freedom also we can say that we should divide it by n minus 1. Okay.
So here okay.
Let's come back and let's discuss this. So this is this particular n1 minus 1 divided by sigma 1 square times sx square follow this chi-square distribution. and this will follow another chi-square distribution. Now comes F distribution. So it's actually the division of two chi-square distributions. So if this is chi-square, so I just forget one more step here. So chi-square n minus 1, so something like sx square divided by n1 minus 1 divided by sy square divided by n2 minus 1. This will follow this fn1 minus 1 comma n2. Okay, if I have two random variables which follow chi-square distribution, so this is a chi-square, this is a chi-square, divided by number of degrees of freedom. So degrees of freedom for sx square is n minus 1, n1 minus 1, and degrees of freedom for sy square is n2 minus 1. So if you divide these two, this will follow a new distribution called F distribution. And the two parameters are degrees of freedom of first distribution and degrees of freedom of the second distribution. So that is what an F distribution means. So simply you can see Sx square. So Sx square, sorry, this is.
Sir, how are you dividing sx square by n minus
This is not
n1
Sx
minus 1?
square. Yeah, this is not Sx square. This is something like what random variables we can. Okay, W and 1, W and W1 and W2. Let's say W1 and W2. So this W1 and W2 are chi-square. So it follows chi-square. Okay, let me write chi-square only. So there is a random variable that follows chi-square n1 minus 1. So there is another random variable that follows chi-square n2 minus 1. Okay, so chi-square n1 minus 1 random variable divided by degrees of freedom of that random variable. So this will be in the numerator, and you divide it with chi-square n2 minus 1 divided by n2 minus 1. So if I wanted to write it very cleanly, so let's say x and y follows, okay, x follows chi-square n minus 1 and y follows chi-square m minus 1, then x by n minus 1 divided by y by m minus 1 will follow f n minus 1 comma m minus 1. So you have two chi-square distributions with n minus 1 degrees of freedom. One is with n minus 1 degrees of freedom and another is m minus 1 degrees of freedom. Then x divided by degrees of freedom of x whole divided by y divided by degrees of freedom of y. So that will follow F distribution. Okay, understood?
Okay.
But just we discussed at the beginning that X follows normal distribution, right? With mu1 and sigma 1.
And that is why I am ran out of random variables. That is why I took
Okay, no problem. Okay, no problem.
maybe
Okay, no problem. Then got it, sir.
P. Okay, C chi-square na C1 C2
C1 C2.
C1 C2, or I simply okay understand it like this. So there are two random variables C1 and C2. C1 follows chi-square n minus 1 where C1 has n minus 1 degrees of freedom. C2 follows chi-square m minus 1, that means m minus 1 degrees of freedom. So C1 divided by degrees of freedom of C1 whole divided by C2 divided by degrees of freedom of C2. This particular thing follows F distribution with parameters. One parameter is degrees of freedom of first random variable. Another parameter is degrees of freedom of second random variable. Okay. So let's compare. So C1 is actually N1. So you just come here. This is what C1 is. This whole is C1. This is C1. And this is C2. Okay. Now I'm just removing this. Now what we have to do? C1, so n1 minus 1 by sigma 1 square times sx square divided by degrees of freedom of this distribution. So it is n1 minus 1 whole divided by n2. What is C2? C2 is n2 minus 1 divided by sigma 2 square times sy square whole divided by degrees of freedom of this distribution. So it is n2 minus 1. So this will get cancelled and we will get sx square divided by sigma 1 square whole divided by sy square divided by sigma 2 square. Okay, if you further simplify this, you will get sx square times sigma 2 square. So sigma 2 square will go into the numerator and sigma 1 square will come into the denominator. So this will follow f n1 minus 1 comma n2 minus 1.
Okay.
Okay.
So
Now
these
there
two
are few.
these two are parameters, n1 minus n. N2
These are
minus n,
degrees of freedom of
both random
2
variables.
pi square.
So n1 minus 1 and n2 minus 1 are degrees of freedoms
Both random variables.
of these random variables C1 and C2.
These are parameters for f distribution.
Yeah, f distribution. So now there are few cases. If there is a subcase, if sigma 1 is equals to sigma 2, then it is pretty straightforward that this particular sx square by sy square follows f n1 minus 1 n2 minus 1. So what is this sx square and sy square?
Sample standard
Simple
Sample variance.
sample variance of the first distribution samples
Distribution.
and the sample variance of the second distribution samples. If you divide these two, this will follow f distribution with n1 minus 1. So the number of samples we take n1 for the first from the first distribution we have taken n1 samples and from the second distribution we have taken n2 samples. So therefore it is pretty straightforward case, pretty straightforward to understand. If you divide the variances, this will follow. When you divide the variances, this is what? This is the primary condition if the standard deviations are same. So when this will be same, we are actually testing that. So if your null is true, then this is true. Okay, don't bring that null and everything. So this is a sub case. Okay, just understand it like that. If your sigma 1 and sigma 2 are equal, so the variances of these two distributions are equal, then the division of these two sample variances will follow f distribution with parameters n1 minus 1 and n2 minus 1. Okay, that is what we get from there. So that is about f distribution, and this is how the PDF of f distribution looks like. So this is.
I have one more question.
Not symmetric about 1, right, sir? It's not symmetric about 1,
it's not
right?
symmetric about 1. I am just drawing that.
I have a question. Let's say the variances, assume that the variance is the same and the mean is not the same. I know they're not coming from the same population, correct? So what do I conclude with this F test? Okay, the variance is the same. In reality, in practical purpose, where do we actually?
The distribution is same, but it is see the curve is same, but it is placed in a different place. That's it. That you will get.
Okay. Okay.
See, so if your variances are same, the distribution, so the cluster, so the distribution of these random variables will be same. If your variance is same, that will give you something like. So these all are we are talking about normal distributions. Okay, almost pretty much similar to normal distribution. So if you are something, it will be like this only. The same shape and the same stretch, it will be there. Maybe the mean is somewhere after something.
Okay. Okay.
Okay. So this will have the same shape that we will conclude.
Okay.
Okay. So yeah, you can consider in a real life example also. Like there are two classrooms, and if you wanted to see, look at how the distribution of marks of two classes are there. Is it equally distributed in the both classes? Matlab the topper who scored in this class and the other class, and the least marks in that class and this class. So are these equal or pretty much equal? So where this is, so the shape.
Yeah, yeah.
Okay. So how,
No.
so if it is a toppers class, maybe if it is out of 100, it may start from 60 to 100. So the least score is 60 and highest the toppers class, as we said, the toppers class, so they can get 100. But the next class may not everyone get 100, but it may vary from 40 to 80. This, with the same distribution, but mean is actually shifted something from right side or the left side. That we will get to know.
Okay, okay.
Yeah.
So suppose if some student. Hello.
Okay.
So suppose if some
Okay, this
students
is
are
how
getting very high values and means very high marks, and some are failing, then also the mean will change, right? Mean of the average means
mean
average
will
of
change, but variance is very different. Variance will be lot more different from
different.
previous case.
Okay.
Yeah, variance will vary, right? Variance will be different.
Variance,
So
because many students are getting
values are here and here. Yeah.
Extreme. Yeah.
So the variance of this and the variance of this variance is greater.
Okay.
Variance of this is greater than this.
Okay.
Okay, because from the mean, so if you subtract each and every random variable, that is what variance is, right? So from the mean, every value is far away, very far than here. Okay.
So this
If
can
you
happen
compute the
because of
variances because of a difficult question, it may weigh a lot of marks. Yeah, that can happen, but variances will vary. So what we are going to test is whether the distribution is equal or not. When I say distribution, it's not about the complete distribution. How far the cluster of, so how where these random variables are placed, is it same for both or is it different? So something like this. So we are going to compare variances of these two data sets are same, more or less it will be same, and this will be different for this. So if you see the data points like this, so if you wanted to compare variance of this to this, the mean may be same, but variances are different. Variance will vary. Variance of this is way far less than the variance of this data points. Okay. So that is what we are going to compare. That is what we are going to see. So there are many elements, out of which one is mean and another is variance. So that is what we are going to test in this particular lectures. In the last week and in this week, we are only worried about testing mean and testing for variance and comparing mean and comparing variance. That's it. Apart from this, we are not doing anything new. Okay. Okay. Shall we proceed?
Yeah.
Yep.
Just a second. I got few questions. Okay. So degrees of freedom and F test. Okay. It's okay. So I hope I answered even in the chart questions. So in the Zoom chart, you have posted questions. After that only, I think I have explained what this degrees of freedom and everything is. Okay, let us look at this PDF of F distribution. How is the graph looking like?
the gamma distribution.
Gamma.
Right tail.
This is right tail, right skewed or right tail.
Right.
So we call it right skewed.
Right skewed.
Okay, this is right skewed distribution. And see here, why we are taking 1 here is F is actually this thing, sample variance divided by sample variance. So two random variables we are dividing, and we are calling it as, it follows F n1 minus 1 comma n2 minus 1. So when we are dividing these two, more or less what happens is the values will be around 1. Most of the time the values will be around 1. So we are actually comparing these two. Fraction, we are looking at the fraction.
Hmm.
And there is a high chance of getting values around 1. Okay, so that is why this PDF has more steeper at these points from 0 to 1. So depending upon this number of degrees of freedoms, this graph will vary. So let me show you how it varies actually. Okay, is my Google screen visible?
Yeah.
So if you want to play around these distributions and look about this distribution, there is called statdist.com. Just like Desmos for graphing. So we have plotting for this different kinds of distributions. So we wanted for F distribution, and let's keep the parameters as something like 10 and 10. So you see the PDF here. Is the
Yes,
screen
sir.
visible, or you have to zoom a little bit? So it's not getting zoom. Yeah. Okay.
It's giving both PDF and CDF.
Yeah, it is giving both PDF and CDF. Right now we will focus on PDF. Okay. So as this is a continuous distribution, your CDF will be like this. It will be like a curve. There will not be any cuts. So if it is discrete, there will be a breaks in between.
Hmm.
So F distribution is also a continuous distribution. So you see this F distribution where our both the parameters are 10 and 10. Okay.
Hmm.
Let me pin this and let us take a smaller value. So maybe 5 and 5. So the red one, so you see the difference. How is it changing? So the steepness will coming to the right side, slowly coming to the right side. If I increase the degrees of freedom. So maybe I can give you one more. So maybe 15 and 15. See this thing. So this blue curve is actually representing F10 comma 10 distribution. And this green curve is actually representing N15 comma 15. Sorry, F15 comma 15. And this particular red curve is representing F5 comma 5. So if your degrees of freedom is less in both the cases,
Hmm.
then the curve will be very much right tilted, right skewed.
Okay.
Okay.
So as you're increasing the parameters, it is more and more becoming straighter.
More and more becoming. So the mean is more and more going towards 1.
Okay.
Or not mean, the peak point.
Peak, yes.
Yeah, the peak
It is
point
going
will
to
come
1.
closer and closer to 1. So if I
1.
increase the degrees of freedom or the parameter values for this F distribution, the peak point will come closer and closer to 1.
1.
Okay, maybe I think 20 won't work. Let me check. Okay, 20 is also working. See. So I have given 20. So you can see it is coming
20
closer
is
and closer
exact.
to 1. So the top
Almost
point
exact.
is something very much nearer to 0.964. Okay. So this is what.
So, but one
this
query
Hmm.
for very high value of n, won't it cross 1 then? Because it's
No,
going towards 9.
it never crosses 1.
Hmm.
Okay.
So it is a converging graph.
Okay.
Maybe something.
Converges to 1.
I think, yeah. So unable to create. Maybe 30, 22, 25, 24. 22 is the maximum thing we can see here.
Okay.
Oh, okay, yeah. So see here. Now this came around 0.993. Okay.
Hmm.
So it will converge. It will converge. If you take more and more values, it comes there and there itself.
So one query over here. This n and m is degrees of freedom. So in one way, it is a number of samples, right? Isn't it?
And 22 is not
Yeah.
23 is the number of samples.
Okay, right. But
N1 minus
that number, whatever number n or m is, that plus one is number of samples, right?
that plus one is the number of samples, and
So
this
what
22
will
and 20
happen if we are having say 100 samples? So how can we fit that thing over here? Because as we see, it doesn't go beyond 22, right? So if we are having say 100 number of samples, so how are we going to interpret over here that thing if it is not showing me?
If it is not, it is unable to create the chart because the chart will take exactly very much nearer to 1. It shouldn't take 1.
Okay.
Exact one it won't.
So ultimately,
won't
it
take
is
the
not able to
exact
create a graph because of the accuracy thing, but we can
accuracy
always
thing, yeah.
calculate, right?
Yeah,
For
you can
very high
always
end.
calculate.
Okay,
Yeah.
okay. My query was that. Okay, thank you.
But
Mhm.
sir, when the samples are very high, wouldn't it just converge to a normal distribution?
This is not normal.
Even when samples are very high?
Even the samples are very high, maybe this will be like something like beta or gamma.
Gamma. Something.
It's not nothing related to normal.
Okay.
F distribution cannot be approximated to normal.
Sir,
Hmm.
so along x-axis, it's number, degree of freedom, right?
No. X-axis is actually the values. The value of this F distribution, it's actually Sx square divided by Sy square.
Okay, and y-axis is, sir? Y-axis is?
Y-axis is the probability. This is a PDF graph.
Okay.
Hmm.
Okay, in PDF, x-axis is x, right? X, which is
Yes.
Hmm.
and this is probability that x is
X
equals
of
to
X.
x. Okay, so if you wanted to deep look into the PDF and CDF of everything, see, you can see here.
This is for F distribution.
This is for F distribution. So you look at the PDF here. Something
Complicated.
very high
Very
standard.
complex.
No need of that much level.
Yes, got it.
Okay.
Values are okay.
Yeah. So this is how, more or less, this is how, depending on this N1 and N2, the PDF of this F distribution will be somewhat right skewed.
Yes.
Okay. So yeah, and F distribution is, this is what F distribution means. So this will follow F distribution. This particular thing follows F distribution. That is what we require. We don't even require what is the PDF, exact PDF and CDF of F distributions. What we require is, if I have two, this is what ultimately you need this. If I have two distributions from which from one distribution I am taking N1 samples and another distribution I am taking N2 samples, and if I don't know the variances of the distribution, then I will compute the sample variances of each of the distributions, each of the samples. So wherein one particular sampling, it has N1 samples, and another case we have N2 samples. So we can compute sample variance Sx square and sample variance Sy square, and if you divide these two, that particular thing will follow F N1 minus 1 comma N2 minus 1 if sigma 1 is equals to sigma 2. If it is not equal, then this particular Sx square by Sy square times sigma 2 square by sigma 1 square will follow F distribution with parameters N1 minus 1 comma N2 minus 1. Yeah.
So in this F distribution, I had to ask one doubt. So when we try to test the test statistic, which is the Sx square by Sy square, it should be greater than 1 plus CR, or it should be
That we
lesser
will
than.
That we will see.
Okay, we have not
We
seen.
just understood what is F distribution. That's it. We didn't
Oh,
go for
okay.
F test.
Okay, test.
Okay. So this is
So,
about F distribution, and this is what the PDF of F distribution looks like. Okay.
so F distribution only functions when the variances are the same.
No, not like that.
Oh, okay.
So F distribution. So that is what I said, right? If the variances are equal, you just divide the sample variances. That's it. That will follow F distribution. If the variances are not equal,
Yeah. Okay.
then
Okay.
multiply it
That's
by
the
sigma 2 square by sigma 1
sigma
square,
one.
then that will follow F distribution.
Okay. But the handicap is we don't know the variances of the population.
We don't know the variance of population, but it will follow these two cases when H0 is true
Yeah.
and
Yeah.
HA is true. In these two
Okay.
cases, when H0 is true, that means sigma 1 is equal to sigma 2, right?
Okay.
So when you compute the significance level or the alpha, so we will use this, right? We will take H0 is true, and then we will proceed to compute the probabilities of type 1 error. Correct?
Yeah.
So that we will see.
Mm.
So right now we have seen what is F distribution is, and this particular F distribution or this particular F test is used for testing to compare variances.
Okay.
Okay. So this is two samples F test. So when you have two samples, two distributions and few samples, N1 samples from the first distribution and N2 samples from the second distribution, and you don't know the variances and you wanted to compare those variances. So sigma 1 and sigma 2. So you wanted to compare whether sigma 1 is equal to sigma 2 or sigma 1 is not equal to sigma 2. So that is what our testing is. So we will set up our null and alternate. Our null will be like simple, sigma 1 is equal to sigma 2, and our alternate hypothesis will be sigma 1 not equal to sigma 2. So this is what the setup is. So we have two samples, and our null hypothesis is both the distributions have the same standard deviation, and our alternative is sigma both the distributions standard deviations are different. Okay. So the test statistic we use is, in this particular case, we use is Sx square by Sy square. Okay. Previously we had used x bar and then we used S square. Now we are using Sx and later we used x bar minus y bar as test statistic. Now we are using Sx square divided by Sy square. And my question is, why not we go like whatever we did for mean? So for mean, what we did, we just subtracted and we took it as a test statistic.
Well,
So why not do the same?
I suppose professor has explained this, sir, a little bit. Like this, this subtraction is not very defined, in case of variance.
Correct. So in this particular case, x bar minus y bar. So that is why I discussed that. So let me just go back. See here, this x bar minus y bar is well-known distribution. It falls under a normal distribution, normal with mean mu1 minus mu2, comma sigma. This is the variance. So this distribution is pretty much standard distribution. Pretty much it follows normal. So we can use that as a test statistic to compare to compute the probabilities. But do we know the distribution of this Sx square minus Sy square?
No.
No, right? So the distribution. So why we not use Sx square minus Sy square is because the distribution of Sx square minus Sy square is difficult.
Sir, but it leads to a different question. Okay, in case of square, in case of variance, it is not very defined. But what about x bar by y bar?
Even then, it is not defined. Right?
Okay.
What is x bar by y bar? It is not
like
defined.
X bar minus y bar we are taking, na? So if mean are equal, then x bar by y bar will be 1, na? Like whatever explanation we are giving for variance, like when variance are equal, it means x square x by x square y is 1, right?
Okay, but you are dividing two normal distributions, right?
Yes, sir.
So this follows normal and this follows normal.
Yes.
So what is the division of two normals? Do
I
you know
don't
any
know.
distribution, standard distribution?
I don't know.
No, right? Okay, we don't have any standard distribution when you divide two normals.
Answer in F distribution, sir, we are taking two samples, right? So can they come from different distributions? Like here, both are coming from normal. Is it possible that one is coming from normal and the other one is
See,
coming from?
other one coming from any other distribution, you can actually approximate it to normal.
Okay. Okay. Going through that logic, we can do it. Huh?
So you can do that coming from that logic. So while the distribution while this particular Sx square by Sy square, just now we have seen this follows standard F distribution. Okay, so that is why we use this as the test statistic. So Sx square by Sy square will be used in place of Sx square minus Sy square. Okay, so understand it like this. So if you have two things, so if I say sigma 1 is equals to sigma 2, I can write it like sigma 1 minus sigma 2 is equals to 0, or sigma 1 by sigma 2 is equals to 1. Both are same. For mean, we use this, we subtract it and equate it to 0. And that is why we take the subtraction, and our main focus will be nearer to 0 in that particular case. Correct? If you remember, if you are testing for comparing means, you will be like mu 1 is equals to mu 2 or mu 1 not equals to mu 2.
Yes.
And the test statistic you take is x bar minus y bar. And you say you will look at around 0.
Yes.
X bar minus y bar, if mu 1 is equals to mu 2, then x bar minus y bar will be 0. So your distribution will more or less lie around 0. But here you see, you are comparing sigma 1 and sigma 2, and we are considering the division sigma 1 by sigma 2, which is equal to 1. So that is why our test statistic value will lie, so most of the times will lie very much nearer to 1. So we are interested to accept our null hypothesis if this test statistic falls very much nearer to 1, very much in the interval of 1. So that is where this test comes into the play. So what is the test? What is the test we are going to do? We are going to reject H naught if this particular T, whatever the test statistic, this particular division. So if the sample variance of one distribution divided by sample variance of other distribution is greater than 1 plus some constant. So I have written it as CR, right side value. So you can take it as right and left. So if this is greater than, maybe you say when you divided these two, you got something like 2.5. So what it tells you, the sample variance of this particular x, random variable x, divided by sample variance of random variable of y is actually 2.5, means this particular x is 2.5 times of Sy square. So this is like, this looks like, you can see the sample variances are very much different. One is actually, if the sample variance of y is 1, the sample variance of Sx square will be 2.5, which is very far from 1. So can I conclude the distribution sample variances are equal or not equal? How will our mind will tend to?
Not equal.
Not equal, right? So if this division is very much nearer to 1, then I think I might guess that the standard deviations are equal, or I won't reject null. I will accept null. So I will accept null. So I'm going to accept H naught if the test statistic value falls around 1. So something left side of 1 and something right side of 1, that we will fix. That critical value we will fix. So this is also a critical value. So why we are having two different values is just because it is not symmetric distribution. So this particular, whatever the distribution, F distribution we have shown, that is a right skewed distribution. Okay, the peak point is not the mean. This is not the mean. The mean will be a somewhat right side of this peak point. So this is a right skewed distribution. That is why the probabilities left side of the mean and the right side of the mean will be different. Okay.
So I'm having a query over here regarding this sx square divided by sy square. How should we choose the value of which one should be sx and which one should be sy? Because that will decide the greater than and less than thing, no? Because if I interchange it by any chance, the entire thing will go wrong.
See, that is why we take within one, right? So something less than one and something greater than one.
Right.
So if,
for example, there are two samples. Okay. Say, for example, weights of babies, female babies and male babies. Now, how will I decide which one should be my SX and which one should be my SY?
See, that usually we will take, see, in this particular course, so I understand what your query is. So we will specifically mention whatever the first random variables or the first distribution given, that is X.
Right. I'm not talking only from the course perspective. Even in real life scenario, if we come across.
See, even in that particular cases, what happens is,
like, is there some kind of test which we can do and decide which one should be the
nothing
first
like
one?
that. Nothing like that to my knowledge.
Because otherwise it can go totally wrong. If I take it by mistake, the opposite one, the test can go totally wrong, right? I mean,
sir, but in questions we have seen that where every first which is coming, that you are taking the questions as X.
and I'm not talking
one
only from that perspective, Manan. I'm talking in general.
Yeah, my question also is that.
I understand. So,
but like, is there anything where I can go through some materials, like in case it is there, how to decide these things?
But
I mean, I don't want to waste everyone's time over here.
Correct.
See, that one lies in taking the defining the H0 and the HA set.
No, ultimately it will be like that. Na, sigma 1 equal to sigma 2 or sigma 1 is not equal to sigma 2.
That is
those are both are like equal. I mean, we cannot decide which one should be taken in the numerator.
This is how it goes. This is what my understanding. So this is how it goes. So which one you wanted to compare with which? So whether you wanted to compare sigma 1 with sigma 2 or sigma 2 with sigma 1. Okay. If it is one variable case, so we are comparing sigma to some value sigma naught, right?
Okay.
So this is sigma distribution, sigma, and we are equating it to some sigma naught. So whether this is equal to sigma naught or not, we are checking for this sigma.
Okay.
Do you understand this?
I think so. I think so. In that case, Sx by Sy in both the cases should give the same result. I think it should. Irrespective, I think whether how we take it, it should work, because ultimately we are checking equality or inequality.
Equality or inequality, I'm not saying that. See, checking. See whether. So these are two different cases. See, this thing is whether sigma 1 is equal to sigma 2 or not. This is this. So, and this is whether sigma 2 is equal to, so we are testing sigma 2 with sigma 1, and here we are testing sigma 1 with sigma 2.
So the one which we are testing should be in the numerator or something?
So see, sigma 1, the one which we are testing will come to the numerator, I guess.
Numerator.
Okay.
So see this particular,
So this distinction will be specified in the question, or these things.
Just 1 second.
Related to this, sorry.
Just one second. Related to this particular course, you don't need to worry about which one to be taken first.
Yeah.
Whatever we define the first samples coming from this particular distribution, that will be X. and second defined samples will be y.
Y. Okay.
Okay, in this particular
sir.
course.
Okay. Sir.
Okay. So apart from that, so this is what my understanding is. Let me go back and check whether this is correct or not.
Okay.
And
Okay, sir. Thank
I
you.
will come back and we can discuss on that. Okay.
Sure. Thanks.
Yeah.
Hello. Sir,
Yeah.
am I audible?
Yeah. You are audible now. You can ask.
Yeah. No. I was saying that just what Kavita was asking related to that question only. That this question can be answered if whatever way we are following, we will learn how to, because all the examples what we have discussed so far, we have discussed whether they are equal or not equal, right? We will learn how to do the hypothesis testing for when they are not equal and one is greater than other. Then that question can easily be answered. But that technique I think we are not covering in this course or
We
what,
are
because
not
all the
covering
questions because whatever question professor has also solved, he has only taken the example of equal or not equal. Even all the activity questions and PH are also talking the same thing. But if we cover when they are not equal, then which one is greater? You remember, like in case of mean, we used to discuss whether mu1 is greater than mu2 or mu2 is greater than mu1.
See,
So
usually we don't worry in standard deviation or sample variances. We don't worry about whether one is greater than or lesser than the other.
But the question is very valid.
Yeah,
Sir.
here we have to
Excuse
worry
me, sir.
about it because later on result. But I think, sir, I'll put it on discourse. I think I don't want to waste everyone's time.
Okay.
Excuse me, sir.
Yeah.
Thanks.
But in the graded assignment question, there is one question number 3.
Week 12 is it?
The question is.
Which week is it? Which week is it?
Week 12.
Week 12, question number 3.
Question number 3, graded assignment.
Okay.
In that, variability in marks of class B is greater than that of A.
No, but there also I think we should take the first sample only. That's what sir is saying.
Yeah. See, here also we are testing.
It won't matter, sir.
Session A had 25 students attending, while session B has 36 students. The there was no significant difference in mean grades. Session A has a standard deviation of 10, while session B has a standard deviation of 5. We concluded the significance that the variability marks of class B is greater than that of A. Okay, so there is you are saying that in the alternative there we have something like sigma 2 is greater than sigma 1. That is what your question is, right? Am I audible?
Yes, sir.
Yes, sir.
So is that the question? Matlab alternative is not it changed from not equal to it's something like less than. So sigma
1 less than 2, sir.
Sigma A less than sigma B.
Oh, in that case, we have to think what to be taken in the numerator and denominator.
The F value given is also changed. 35 comes first and 24 comes second.
Bigger and smaller value.
Here you can understand it clearly. So whatever I said is correct. So here they are comparing class B with class A, not class A with class B.
Yes, sir.
Okay. So what the final statement says, can we conclude at the significance level 0.01 that the variability in marks of class B is greater than that of A. So we are testing for variability of class B with variability of class A.
So the B should be taken in the numerator.
B comes first. Yeah, B comes first.
Okay.
A goes next.
Okay.
Hello. Hello.
So when we are taking different values of C, CL and CR, then we are automatically sorting out this issue, no, sir? SX, whether we take SX in denominator or SY in numerator. That's why we are taking different values.
Even I thought the same, but what happens is sometimes, see this CL, 1 minus CL may be very closer to 1 and 1 plus CR may be far from 1.
But
and
that will happen when we interchange the denominator and numerator. When we interchange the denominator and numerator, that thing is going to happen. One value will be near to 1 and one value will be far to 1. Suppose we take 4 divided by 5.
Okay,
It
4
will get
divided by
0.8.
5. Okay. And 5 by 4
5
is
divided by 4, 1.25. So CR will be 0.25, CL will be 0.2.
Oh, I'm not telling this. Okay, let me give you a small example. Okay. So you say you reject when it goes below 0.8 and you accept when it is 1.1, above 1.1. Sorry, below 1.1 and above 0.8. Okay. So this is what your CL and this is what your CL and CR values are. Okay.
1.25.
So 0.7. So, no, this CR and CL is in our hands.
Yes,
and it's in significance level hands. We are not the one
yes,
fix it. Okay. Those critical values we will get it from once you fix the significance level. Okay. So if your 1 minus CL is somewhat 0.7, if 1 plus CR is something
That's
like
what
1.1,
that,
you take it like this.
that's
Okay.
what I was saying. Sir. The CR and CL will be calculated accordingly. Accordingly, the positions of SX and SY.
Is it so?
I think so.
No, but we are not checking the position of CL and CR. Na? We are checking 1 minus CL, the entire thing. So it will matter what we are taking in numerator and what we are taking in denominator. We are not calculating CL or CR. We are directly taking 1 minus CL.
Okay, we will discuss this very after 5 minutes. Okay. Let us, as of now, let us continue with Sx square by Sy square.
Yes, sir. Yes.
Let us complete this F distribution, F test. And
So
then
take
we
one
will
example.
and then we will take one example and see what happens when it is Sx square by Sy square, and what if it is reverse Sy square by Sx square, and we will do.
True.
Okay, that will give us more clarity.
Yes, sir.
Okay. So yeah, so the acceptance region, what am I saying is this Sx square by Sy square. So we are comparing the standard deviations. So that is why this Sx square by Sy square will be more or less, if it is very nearer to 1, either left side or the right side, we intend to accept null. So what we say is, so the difference, the division is very much equal to 1. That means the sample variance of x and the sample variance of y more or less very equal. So the sample variance is only equal, then the distributions variances are also equal. Then we will conclude and accept null. Accept null when it is in this particular region.
True.
Okay. And beyond that regions, we will reject null. So in this region, we will reject null. And in this region also, we will reject null. And why we are getting, so usually we will get something like, so if it is mu naught, so if this is mu naught, and we will take minus c and plus c, right? Mu naught minus c, mu naught plus c, something like this, right? How much I shift to the left side, I will shift the same to the right side, because normal distributions or the t distributions will be symmetric around mean. Okay, got the point? But here have F distribution, our F distribution is right skewed distribution.
It's not symmetric.
So it's not symmetric. So how we define this C? So this C and this C, this and this is alpha by 2. This is alpha by 2. That is how we fix this C. Correct?
True.
Everyone? You understand this thing, right? When it is normal,
Yes, sir.
in the test statistics case, when we have the normal, if it follows normal, then this particular C or the minus C, we are going to fix with alpha, depending upon the alpha. Correct? And this particular area will be alpha by 2 on the right side and alpha by 2 on the left side. Combinedly, the rejection region of H naught, which is alpha.
Okay.
Correct? Even here also we follow the same thing. So this particular area should be alpha by 2. So depending upon alpha, so we will fix this 1 plus CR. So this particular CR, this right side critical value will be fixed. Whatever the area to the right side of this is, should be equal to alpha by 2.
So
And
this will happen only when sigma 1 is equal to sigma 2, no? Otherwise it won't, right?
Yeah, this will happen. See,
Yeah.
if we are computing for alpha significance level, what it tells you, probability that you are rejecting H naught
Conditional
when H naught is true.
True.
When will H naught will be true? It will be true when sigma 1 is equal to sigma 2.
Oh, right. Okay.
Right? So if this is what we take, and we are computing the probability of rejection region, which is alpha. Correct?
Yes.
So alpha is nothing but the probability of rejection region where sigma 1 is equal to sigma 2. So probability of rejection region in the normal is actually, as it is symmetric, you can divide alpha by 2 on the left side and alpha by 2 on the right side, and you can compute the critical value. Okay. But here, it is not symmetric around mean. So it is actually right skewed distribution. So what happens is, this particular, the area alpha by 2, this alpha by 2 may be different from the point, from this point to this point. So it may move some CR, critical value CR, right side, and may not be equal. The left side may not be equal. It may just move something CL, which are different. CL and
both
CL.
are different.
Yeah. So you move, if you move CL units left side, you might reach alpha by 2 area. And if you move the same CL, you might not reach alpha by 2 area. Maybe the area is greater than alpha by 2. So you should make the rejection region probability should be equal to alpha by 2. So that many units we will move to the right side, and that many units we will move to the left side. Okay.
So
That is why this.
Do we need to check for both sides separately? Do we need to check both sides separately?
No. So in computation, what happens is sometimes you require CL and sometimes you require CR. So in the question, look at the question. Look at the question.
How to find 1 plus CR or 1 minus CL means what one will help me in rejecting my null hypothesis, or we have to compute both the values?
No need to compute both the values, but you observe this, how we compute alpha. So we know alpha is actually probability of reject H naught when H naught is true, correct?
Yes.
We are going to reject H naught when H naught is true.
That's the extended definition.
So what it tells, it is actually probability that T falls left side of 1 minus CL, if it falls left side of 1 minus CL, and the right side of 1 plus CR, then we are going to reject.
Total alpha.
That will be the alpha. And probability that T is less than 1 minus CL, given sigma 1 is equal to sigma 2, plus probability that T greater than 1 plus CR, given sigma 1 is equal to sigma 2. Okay. And this is a sum, this will be equal to alpha, and we need in the both sides, we need with same probabilities. So the rejection region should be with same probabilities. That is why it is alpha by 2 and alpha by 2. So this is alpha by 2. So simply how we can write is alpha by 2 is actually equals to which is equals to probability that t greater than 1 plus CR given sigma 1 is equal to sigma 2.
But said both regions are not equal. Just now we discussed that it is not.
It will be one.
Probabilities are equal. Area under the curve should be equal. So this is the area under the curve, and that will be equal to alpha by 2.
And both should be left and right should be equal. I mean,
Area
area itself, it should be added now, sir.
Yeah, it should be added, and that will be the alpha.
Sir, but
Right.
as Manan said, how will we understand which to calculate? Because sir has also explained that
true.
in the lecture, but I didn't understand it.
It's very confusing.
So now
Which one should we consider?
So t, just substitute t. So probability that. So as we know, sigma 1 is equals to sigma 2, and t is sx square by sy square less than 1 minus cl. So this is equals to alpha by 2. And from here, what you get? So this xx square by sy square, this follow f distribution, correct? F distribution. If sigma 1 is equals to sigma 2. So that is given. So that means this will follow. So maybe this is less than. So this is f n1 minus 1 comma n2 minus 1 of 1 minus cl is equals to alpha by 2. So
yeah, right.
Okay. So this is 1 minus cl will be equals to f inverse of something like n1 minus 1 comma n2 minus 1 alpha by 2. So cl will be something like 1 minus
plus
1 minus.
Oh, sorry. 1
f
minus.
inverse n1 minus 1 comma n2 minus 1 alpha by 2. You see this f inverse of inside there is term alpha by 2. Okay. So we have alpha by 2 if you are going to calculate the left critical value. Okay.
Okay.
So if I am computing the left critical value,
1 minus.
So if I am computing CL, so it is 1 minus f inverse of n1 minus 1 comma n2 minus 1 of alpha by 2. So that means what should I give to you? So in the given it should be, so if f inverse of n1 minus 1 comma n2 minus 1, so let's say alpha is something like 0.05. So alpha by 2 will be 0.025. If this is given, f inverse of this 0.025 is given,
okay,
then you should compute the left critical value.
Oh.
Okay.
So what happens again, sir, this is from the exam perspective, but otherwise, like, will it matter if I calculate something else?
No. If you don't know the distribution, if you know the distribution values, like if you use collab or something, if you know the distribution values like f inverse of this particular thing, if you know this, you can compute the left critical value and the right critical value both.
Okay. Ultimately, it will be independent of whether.
And sir, can it happen that one of the value is matching, falling within the limit, but the other one is not falling? Can it happen that way?
No.
It being ratio, it is not possible, I think, ma'am.
No,
but CL and CR are different, na? So this is quite a possibility. It's not the same. I mean, logically, I don't know.
So you are asking that?
Means, for example, for a particular example, 1 plus CR, the value is falling within 1 plus CR, but the other side value is not falling within 1 minus CR. Can it happen?
So one is greater and another one is not less than.
Yeah.
Or it might be.
Or vice versa.
Vice versa.
Our test statistic value is a static value, correct? So it's a fixed value. If that particular value falls in this region, you accept. So this t is a fixed value. It won't have two different values.
Not getting actually. No, but CL and CR are different, na, sir? So 1 minus CL and 1 plus CR.
and CR may be different, okay? It is
right.
Different.
Yeah.
Okay. You have some fixed value for t.
Yeah.
you compute T. You know how to compute T? If
Yeah.
you
We are
sample
disputing actually.
variances.
Right.
If you know the sample variance, you just divide both the
Yes.
sample variances.
Yep.
Once you divide both the sample variances, it might fall somewhere else. Matlab, it is a constant value now. Your T is
Yeah.
constant now.
Yes.
Okay.
Yeah.
So either you check whether your T is greater than this 1 plus CR, you will accept. Sorry, you will reject.
Okay.
Okay. If it is less than 1 plus CR and if it is greater than 1 minus CL, then you accept.
Still, greater. But can it ever happen that it is lesser than, no, it is
1
greater
plus
than 1
CR.
minus CL, but it is, no, it cannot go that way.
It cannot go that way, right? So that is what I mean. There will not be any two values. Either T may be here. So your value maybe T falls in this particular places where you will reject. Maybe your T falls here in between.
So, but in this scenario where you're drawn, you are ideally taken CL is almost equal to CR, na? So if it is not that way, CR is a little bigger than CL, and it can fall between, no? Logically it can, right? Because CL and CR are not actually the same. So for example, CR is say 1 point, I'm giving just a hypothetical value, 1.5 is CR and 1.2 is my CL. And if it is somewhere 1.3, so what will happen?
Okay, I will tell you. I got the point, but okay, let me try to convince you with this if I can. Okay, so you know one is in between, right?
Yeah.
Yes.
Okay, so this is 1. Let's say this is 1. So if your T is less than 1, it falls in this region. Pakka.
Right. Yeah.
And if T is greater than 1, this falls in this region.
Yeah.
Okay.
Yes.
Now, you know, once you compute the test statistic as x square y square, you will get to know whether it is less than 1 or greater than.
Yeah.
Okay. For suppose it is less than 1. Okay. For suppose.
Okay, it's a static value. Okay.
It's a static value. For suppose it is less than 1. What you will check? You will check for whether it is less than 1 minus CL or it is greater than 1 minus CL. So if it is greater than 1 minus CL, it falls in this region and we are going to accept.
Understood. So in real life scenario, we can calculate Sx square by Sy square, whatever value is coming, accordingly we can select either 1 plus CL or 1 minus CL and decide. Okay,
correct.
got it.
So if this value is greater than 1, you go for 1 plus CR checking.
Got it, sir. Thank you so much.
If this is less than 1, you can go for 1 minus CL checking.
Achha.
Yes, sir.
So we have to, based on the T, we have to calculate, right?
Yeah. So based on the T.
So
okay, got it.
For all cases, or will this change?
No, this is what. So if your T is greater than 1, it will fall in this green region somewhere. So you just compare it with whether your T is greater than 1 plus CR or less than 1 plus CR. If it is less than 1 plus CR, it will be in the acceptance region. So this is the acceptance region. Okay.
No, I was saying that if this T is greater than 1, you said 1 plus CR. So this will be true for all cases, right?
You can check for all the cases. But what happens is if you don't know the distribution or the distribution values hasn't given in the examination. So we have given one thing. Okay, we have given if this particular thing is given, then you can compute the left critical value. If I wanted to compute the right critical value, that will be like something like, you see, from here only. It is T greater than 1 plus CR, alpha by 2. So what it will be? So probability that T greater than 1 plus CR. So this T follows F distribution. So this I can write it as 1 minus P T less than,
T
1,
less
plus
than
CR.
1 plus CR.
And this will be like 1 minus F N1 minus 1 comma N2 minus 1, 1 plus CR. and this is alpha by 2.
Yeah.
Now if you solve it completely, you will get CR as
1 minus
1, CR as F inverse of n1 minus 1 comma n2 minus 1, 1 minus alpha by 2 minus 1. So this is what you are going to get. So you just simplify this. So this F comes to the left hand side, 1 minus alpha by 2, F inverse of 1 minus alpha by 2, and you subtract 1 from it, you will get the CR. So now you see, you need to know this 1 minus alpha by 2 value, F inverse of 1 minus alpha by 2. If alpha is 0.05, 1 minus alpha.
0.07.
So this is something like
0.975.
975, correct? So if we have given you this value, and if you are using, try to compute CL, you won't get.
Oh, I see.
Right? Sure. Even this is one way of checking. So whatever I said above, that is the best way to check. And if you are confused, whatever the values we give you, that will give you some hint which one need to be checked.
So if it is 0.025, we can check for one.
If F inverse of 0.025 is given, that will
we
be
can
for
go
CL.
for CL. Okay.
But still, I think what sir has explained earlier, I think that is the best way, because this way we can end up wasting some of the time, some of our time.
Right, correct. So you can choose.
T statistics will give a more clear picture. T statistics. Like what is the value of that ratio? If it is more than 1 and less than 1. That gives more clear picture.
So you can go with this way. Okay.
Test statistic.
So test statistic. This is how we compute the significance level, and we can also compute the power of this F test, which is actually 1 minus beta, and we know what is beta, probability of type. What is beta?
Probability of
accepting null when alternate is true.
Alternate is true.
Type 1 or type 2?
Type 2.
Type 2 error.
Type 2 error.
So not every time we give you this. Okay. Sometimes we ask you this also. Okay. So don't forget these things. Type 2 error is actually accepting H0 when HA is true.
Correct.
Okay. So if I want, when will I accept H0? So you can see the acceptance region. So this is in this region I will accept H0. So what is the region? It is in between 1 minus CL to 1 plus CR.
1 plus CR. Okay.
So that is what we have taken. When T is in between 1 minus CL and 1 plus CR, given HA is true. When HA is true, the standard deviations are different. The variances are different. So sigma 1 is not equal to sigma 2. Now we have T as 1 minus CL less than Sx square by Sy square less than 1 plus CR. So will this follow F distribution if sigma 1 not equals to sigma 2?
I think ratio follows F distribution.
It should still follow, sir.
It will still follow.
It should still follow, yeah. But we have to add 2 things, I think.
Add 2 things.
Like 1 minus CL, that one plus this one, kind of. That's what I think. Because ultimately it is Sx square by Sy square, so it should follow.
I think it is the ratio which follows F distribution, so it will follow F distribution.
Yeah, exactly.
Hello. Have I lost the connection or sir has lost the connection? Hello.
Hello.
I think sir has lost the connection.
Sir has lost.
Thanks for responding first. Virtual classes, it's so
1.5 are gone. How is preparation of everyone? How is preparation of everyone going? Hello.
And the silence itself is telling you, right?
Sorry.
The silence itself is telling you, right?
That will be known on 7th of August.
No, before that.
Preparation.
That's okay. True. I thought I lost the connection or
I think only Manan is well prepared.
No, no, no. I'm very much behind.
Hello.
Yes, sir.
Yes, sir.
Welcome back.
Congratulations, sir.
Let me get the co-host access.
Yes, sir. Yes, sir. Please take that.
So when sigma 1 not equals to sigma 2, you should tell me now. Will it follow F distribution or no?
I think
Gamma distribution.
Gamma.
I think it should follow because ultimately
Yes.
it is the ratio, right? So
the ratio which follow F distribution.
Everyone agree?
No doubt.
I think we have to divide Sx by sigma 1 and Sy by
sigma 2. Yeah.
Oh, yeah, right.
Correct.
Are you sharing your screen?
No, I am about to share my screen. Okay. In the start of the lecture, I have told this. So we have proved this Sx square by Sy square times sigma 2 square by sigma 1 square follows F distribution.
Okay.
If sigma 1 is equals to sigma 2, then only this Sx square by this particular thing will go to 1, and then this Sx square by Sy square will follow F distribution.
Okay. Right.
If sigma 1 is not equal to sigma 2, then this will follow
multiply.
This will follow F distribution. So in order to make that as F distribution, what we will do, we will multiply
sigma 2 square.
Yeah. So CL times sigma 2 square by sigma 1
1 square
less than Sx square sigma 2 square by sigma Sy square sigma 1 square less than 1 minus CR
1 plus CR
sigma 2 square by 1 plus CR. So this will follow
F distribution. Okay. F
What we did
sigma
say?
1.
What we did say? We were asking that whether the ratio should follow F distribution or not, sir. What we did after that, sir?
What we did, in order to convert to normal, if your random variable is not normal, what will we do?
We subtract
given divided by sigma.
Yes.
Sigma.
All those things we did.
So in order to convert to standard normal. So now we have Sx square by Sy square, but that doesn't follow F distribution. In order to convert to F distribution, what we do is we multiply sigma 2 square by sigma 1 square.
Okay.
And this will follow
At the beginning we discussed that, sir, but at the beginning we discussed that it is the ratio and which is following F distribution, sir.
If and only if sigma 1 is equals to sigma 2.
Okay.
That point you missed, I guess. Okay. So now what this is? It's actually from here on it will be like so something like this.
Like mod.
Not mod.
No, not mod.
It is square, everything.
F of.
Okay, you can do it like this. We are not worrying about beta, right? So we are not worrying about beta. We want 1 minus beta, which is power of the test. So this is beta, and we require 1 minus beta. So what is 1 minus beta? If beta is probability of accept H naught when HA is true,
So 1 minus beta is
1 minus
Reject
beta.
H naught
H
when
naught.
Reject
H
H
is
naught.
H is true.
When H is true. Reject, yes.
We reject H
Hmm.
naught. Correct. So when are we going to reject H naught?
When sigma 1 is not equal to sigma 2.
When are we going to reject?
When that is greater than 1 plus CR or less than
Yeah.
1 minus CR. Yes.
So this particular rejection
Okay.
region is same, right? So probability that T less than 1 minus
Okay.
CL given HA will be equal to probability that T greater than 1 plus CL CR
Yes.
given HA, right? See, the probability of rejection, left side and the right side both are equal. So that is what we are doing in the above. So that is why we get CL and CR differently.
Mm-hmm.
So this both will be equal to half of 1 minus beta.
Half.
These are just the computations, okay? So the same T is actually Sx square by Sy square.
So this half why you have given?
So this probability of rejection region is combination of these two, right? So it's actually, this is actually probability of T less than 1 minus CL given HA plus probability of T greater than 1 plus CR given HA. Okay. So sum is 1 minus beta and both of them has equal probabilities. So each of them will have 1 minus beta by 2 and 1 minus beta by 2.
Okay.
So here we will not multiply by sigma 2 square and sigma 1 square.
We are going to multiply. We will. So this is sigma 1 not equals to sigma 2. So in order to compute this probability, we will convert this to F distribution by multiplying sigma 2 square and sigma 1 square left and right hand side. Okay. Now what is this? This follows F distribution. And this probability will be equal to F n1 minus 1 comma n2 minus 1 of 1 minus CL sigma 2 square by sigma 1 square. Correct? So this will be equal to 1 minus beta by 2. So from here you can get 1 minus beta, which is power. So 1 minus beta is actually 2 times of Fn1 minus 1 comma n2 minus 1 1 minus CL sigma 2 square by sigma 1 square. So these are our computations, that's it. So the main key is to get these things. So what is the power and which is the acceptance region and rejection region. So that is why I spend a lot of time on giving you some idea about how to find the acceptance region and rejection region. So if you get this acceptance region and rejection region, then everything will follow. Everything is same standard computing alpha and power. Okay, depending upon alpha and beta, we will conclude whether this test is good, bad.
This is how power is calculated, right?
This is how power is calculated. And I don't think we asked you any questions on power. So this is just for your understanding.
Sir, because in the lecture also sir has tried to solve this as an exercise for power.
So this is how you compute power. Okay. So you try it by yourself. Power is not that difficult, but this is what it will.
One question. For power, why is it twice when the curve is unsymmetric? But
for power?
No, when you put it as CL and CR, I'm reading it as they're not being the same values, correct? 1 minus CL. Yeah. But when it comes to power computation, the assumption is that they're going to be symmetric, or?
No. Whatever we did for alpha, same thing we have done for beta. 1 minus beta.
Okay.
Nothing. There is nothing changed. So the same rejection region we are talking about.
Okay.
The region is important to find.
Yeah.
Okay. Yeah. So I'll just quickly recap what we did in the last few lectures.
Sir, are we going to discuss two cases when they are not equal, be it 2 sample G test or 2 sample F test?
Are we
Hello?
going to discuss?
When both are not equal, whether it is a two sample G test or two sample F test. Like till now we have discussed either mu1 equal to mu2 or alternate is mu not equal to mu2, right? So are we going to discuss that whether one is greater than other or other is less
We
than?
will see. We will see. If I can take 5 more minutes, we will see. But this is how the tests are being done. Okay. And let me just quickly give you what all tests we have used and in which situations we can use a particular test. So if you have only one sample, one distribution like this, and there are some n samples coming from that one distribution, and you know the distribution mean, you wanted to test for the mean, and the variance of this particular distribution is known, is given. So this is very common, very rare cases. So knowing the variances and you don't know the mean and you are testing for the mean, very few. So by looking at the clusters, very
Z test, right?
So what test we use is the test statistic will be sample mean, and the alternative may be mu greater than C, mu less than C, or mu not equal to C. And the test will be like the same signs it will follow. If the alternative is mu greater than C, we are going to reject null if our test statistic value is greater than some critical value. So if it is less, it will be less. If it is not equal, then the difference between
absolute value.
Absolute. So T minus mu is greater than
C.
Yeah. So is this correct? T minus x bar minus mu is greater. Correct.
Yeah.
So if the difference is greater than some critical value, we are going to reject it. And how are we going to compute alpha?
Sir, one small doubt here, sir. Hello? Just come to that. Yeah, these three cases, sir. These three cases only, sir. So with the help of symbols, we come to know that which one is right tail and which one is left tail, right? Let us take the first one is right tail, right? So we here only, sir. Yeah, first one is right tail test, right? So then how we convert it, how we standardize it? Generally we write T minus mu divided by sigma by square root n, and then on the right hand side also we do C minus mu divided by sigma square root n, right? And the same way we do for left-handed test also. But when it comes to two-tailed test, then we simply write that T minus mu divided by sigma by square root 1. C we divide only C by sigma by square root n. We don't use mu there, sir.
Yes. Why? So whatever the operation the left hand side we will do the same operation for the right hand side.
Yes.
Anyway, you have mu in the left hand side in this particular case.
Yes.
So no need to again subtract mu. So you just enough to divide sigma by root n on both sides.
But when we do one side test, then we subtract, no, sir. When we do one side test,
we subtract mu? There is no mu term in the left hand side. So that is why we subtract mu on both sides. And then we divide sigma by root n on both sides. Okay, whatever the operation you do on the left hand side,
I do on both sides.
You should do on the both sides, and ultimately you should get T minus mu by sigma by root n, because this will follow Z.
So are we concluding that in the in third case, my test statistics is mod of T minus mu is greater than C? That is my test.
This is your rejection region.
Okay. So it is already there.
And your random variable here is T minus mu.
So this creates a confusion because in many slides we have taken mod of T is greater than C. Hello.
In that cases we are going to test around 0, I guess.
Hello.
Hello.
Am I not audible?
No, you are audible, sir.
You are audible.
Okay. So,
yes.
Okay. So in this case, what we do is we convert this T to T minus mu by sigma by root n. So this we know that this will follow standard normal.
Hello, sir. Am I audible?
Yeah, you are audible.
I think I had lost a connection for a few seconds, sir. No, I was saying, sir, the confusion came, sir, because in many places in slides it is written that mod of t is greater than c.
See,
that
why
has been
it is,
taken as
I can tell you. See, if you are comparing your mu, or this particular mu is 0, then it is enough to write directly mod t greater than some c. Okay. So those are the cases, I guess. Those are sub cases. Okay.
But sir, all my G distribution have mean 0 standard deviation 1. Whenever I am standardizing, it means I am converting my random variable into standard random variable, right?
But this mu is expected value of x, not the standard normals, the distributions.
Distribution mean.
This particular x. This is not following normal 0, 1. We are converting, we are approximating this
to standard
particular
normal.
X random variable to standard normal.
Yes,
how we
by
do
doing
is
that operation,
by doing this operation.
Minus expected value of x divided by variance of x, right?
Root over variance of x.
Root over variance of x. Yeah.
That will be standard normal. Okay. So ultimately you should bring this thing. So whatever you have, so you do some multiplications or divisions or subtractions, you should get this thing. So already I have t minus mu, that is why I only divided by sigma by root n.
Sigma by root n.
Okay.
Yes.
So this is how we convert to standard normal. So we are converting to standard normal and we are using standard normal distribution and we are computing the probabilities. So that is why this test is called Z test. So you can compare, I guess. So whatever the distribution we use for the computation of probabilities, that particular distribution name itself is named as the test name also. So this is Z test or the Z test. So this Z test is applicable only when you know the distribution's variance. So this particular thing is known. Okay. What if it is not known? So here the same setting, but the only change is your distribution variance is unknown. You don't know the distribution variance. Then what happens is the test statistic will be t itself. Okay. And we take some n samples. Once you take these n samples, we can compute the sample variance. Okay. So we can compute this sample variance and we will substitute in place of distribution variance, we will substitute sample variance. Okay, we are just replacing sigma with S. Okay. So the same thing. So null will be that we are actually testing for the mean only, and the test statistic is sample mean. You are going to reject if it is t greater than c, t less than c, t minus mu greater than c. And how do we compute alpha is if h naught is given, then this t minus mu, you can see instead of sigma, we got S.
Sample
so
standard deviation.
So where S is sample standard
deviation.
So this is what S is. Okay. And this will follow a new distribution which is different from Z distribution, which is called students T distribution. With
Sir, why we call students, sir?
Just named it like that.
Just named.
Yeah.
Okay.
So this is called again the degrees of freedom. Okay, there are n minus 1 degrees of freedom for this T distribution. One interesting fact about this T distribution is if n is tending to infinite, that means your degrees of freedom is going to infinite, then T distribution follows, any guesses?
Normal.
Normal. Standard normal.
Normal.
Okay.
Okay.
So,
So if your degrees of, depending upon this degrees of freedom, this T distribution, actually if your degrees of freedom is going to infinite, then this particular T distribution will follow standard normal.
Okay.
Okay. So this is one interesting fact. You can combine, you can connect T distribution with standard normal distribution in this way. Maybe you increase the degrees of freedom. So how can we increase the degrees of freedom? You take more and more samples. By increasing more and more samples. So you can actually approximate.
So here also parameter is degree of freedom, huh?
In this degree of freedom, correct. So depending upon the degree of freedom, so the value changes.
But sir, one query over here. You said that it will follow standard normal. I agree. But thing is, when in the earlier lectures, it was also said that if we take like more and more n, all the distributions start following standard normal, right? Generally.
All the distribution don't follow
all the samples, not all the
but almost it will, approximately it follows normal, correct.
So like, I mean that approximately is almost similar, right? I mean,
almost.
So actually it is true for everything. Rather,
no. Maybe the distribution may be different, right? The variance may be different, right?
Okay. Okay. Standard normal. Okay. It will not follow standard normal. It will follow only normal. Okay.
It will follow normal and then you standardize it again.
Okay. Got it. Thanks.
But this will follow standard normal.
Yeah. Okay.
So I already told you, right? Just go with this, open the statsdist.com. Okay. In that also you can actually look at, you just give some random values to n here. There is T distribution. You just pin some n values. You keep increasing your n. And you also pin your standard normal. So as n keeps on increasing, this will actually come closer and closer to the standard normal graph. Okay, you can check that.
So one query here. So here you have written that as n goes to infinity, but in most textbooks it is said that T distribution is generally used for samples less than 30 to 50. If it is more than that, it is generally considered as normal distribution.
See, that is what n tends to infinity. See, even for n is equals to maybe something like n is equals to 50 itself, it will more or less follow standard normal. Okay. Very, very much approximate. You can approximate it. Something like that. So that is why I'm telling you, just go to this statsdist.com. Okay. Statsdist.com. There you can actually play, you just change the parameters and you can just see the graph, how it is changing.
Okay. But in end-term exam, it will be mentioned which distribution we have to use. For a given question.
See, everything, this particular setting we will give. If it is z-test, this is the setting. If it is it. The main thing is you should identify which test you should do. That is the thing you should get from the question. So if you know which test to be followed, I think we will give you this settings, I guess. So if it is z-test, this is the setting. If it is t-test, this is the setting. If it is f-test, this is the setting. This is how the settings. Okay. But you should identify whether you should use f or t or standard normal. So that is the main key. Okay. So that is what we are going to check.
In case of t-test, sample standard deviation would be given in the question, right?
In case of
t-test,
sample variance will be given.
Or sample
and variance distribution will be like something like unknown
sigma
parameter.
square will be unknown.
From that you should identify, okay, this is the setting and I should use this t-test.
True, sir.
So identifying the t-test is the task given to you. Once you identify these all things we will give you, maybe you should calculate the probabilities. That's it. Okay. And this is about t-test.
Sir? Sir, in previous case, my random variable was G, right? In case of G test, my random variable is G because we are standardizing everything, right? So what is random variable here? It is T. T is my random variable here.
In this case?
Yeah, in case of t distribution, what is my random variable t?
T minus mu by S
For this
by...
big expression.
Instead of sigma,
So
you will
this
have...
is my S by square root n. So this is my random variable, right?
Yeah, this will follow T distribution. Correct.
And T distribution, here parameter is n minus 1, which is nothing but degree of freedom.
Degrees of freedom, yeah.
So what actually it signifies, like in case of normal distribution, we talk about mean and variance, right? Here what it signifies actually? That we are taking this much sample, that's it only.
Depending upon number of samples, your probability values will change. Hello?
Yeah. Yes, sir.
So if I take only 10 samples, okay, by looking at the 10 samples, I cannot actually guess the distribution variances, right? If I don't know. But I can compute the sample variance, and the error between sample variance and the distribution variance will be, there is a huge error, maybe some error, right? So with that error, we will compute the probabilities. Considering that error, we will compute the probabilities. So that is why this S is there here. So if you take more and more samples, this particular S slowly converges to sigma.
Okay.
So that is why,
So the parameter of T distribution only tell me the number of samples which I have taken.
Number of samples you have taken, and depending upon if you take 10 samples, this particular T minus mu by S by root n table will be different. So there are different tables.
There are different tables.
T100 table, T99 table is different from T100 table.
Yes, sir.
Okay. So
and here we are using the term sample variance, right? S square is sample variance. So is there any difference or relation between sample variance and mean of sample variance?
Mean of sample variance.
Like sigma square by n we take na here, like here we are taking na sigma square by n.
That is variance of sample mean.
That we call as a variance of sample mean, right?
So that is expected value of sample variance. Oh, sorry, that is expected value of sample.
No, that is variance
of sample mean. Yeah, that
is sigma square by n.
So variance of sample mean will be sigma square by n. That is completely different picture.
These two terms are a bit confusing. Okay.
Yeah, terms are confusing, but
very much.
This is completely different case. Okay. Yeah, this is another setting where you are testing for variance now. It's not mean. If you are testing for variance, our test statistic will be S square. Now before that we have sample mean, but now we are having sample variance as the test statistic. So we are going to reject H0 if S is greater than C. Okay. So if this particular setting is there, we use chi-square test. So for sample variance testing for one sample, if you have only one distribution, we use chi-square. So how do we compute alpha?
Sir, in this case also, if instead of sample variance, if some list of samples are given to us, then we will have to compute the sample variance.
Yeah, compute. You have to compute.
Okay.
Using calculator, you can compute.
Calculator. Okay.
So how do we compute alpha? You compute S square, right? We know S square. And n minus 1 times S square divided by sigma naught square will follow chi-square n minus 1 distribution. Okay, from here, you just have to multiply n minus 1 and sigma naught square and then do some manipulations to get this. And from there, it will convert to chi-square distribution. So as it is converting to chi-square distribution, and we require probabilities of chi-square distribution being used in this problem. So this particular test is named as chi-square test.
Here we are talking about variance, right? Estimating variance of the population. Right?
Yeah, estimating variance of population. Testing for variance.
Testing for variance, not estimating. Yeah, testing for variance.
Yeah.
So here also there can be a case of two-tailed test.
Yeah.
No, there can be.
There can
be, but these are some standard tests.
Standard is right-tailed. Okay.
Yeah, standard is like right-tailed test. Okay.
Yes, sir.
And that is about chi-square. So there are only three three standard tests we have: testing for mean when variance is known, testing for mean when variance is unknown, testing for variance when for only one distribution samples we are considering. And there is one more case where it is testing to compare means.
Okay.
So when do we compare two means? If we have two different distributions and two different samples I am taking. So maybe I call it N1, N2. So like this, if I am taking, if I am going to compare whether this mu1 is equal to mu2 or it is not equal. So for that, test statistic will be y bar minus x bar or x bar minus y bar. Okay, whichever you take, we are going to reject h naught if mod of t is greater than some c. So this is what your confusion, right, Ganga Prasad?
Which one, sir?
This one. Only
Yes,
mod
yes.
t is there.
Yes, yes.
Nothing.
This one is also in case of mean, yes.
Yeah,
Yes.
yeah. Because you see, when we are comparing two means, mu1 minus mu2 is actually equal to 0.
Here it is clear, sir. Here I am not having any doubt in case of two samples. I was having doubt in case of one sample.
Wherever it is mod t, then that means we are comparing it to mu is equal to 0 or not.
I will go back to that slide, sir.
Yeah, yeah, you go back to that slide and just check.
Yes, because there are a couple of places in case of one sample I have seen that.
So here also what we do is this particular t, whatever the t test statistic we have, it actually follows normal 0, some variance sigma t square, where this sigma t square will be sigma 1 square by n1 plus sigma 2 square by n2. Okay, so if it is n1 and n2, this is how it will be.
So in this case, the two samples should have same distribution, right?
In this case, if it is different distribution also, you can approximate it to normal.
Okay, okay.
So ultimately we never said it is normal, but we have taken expected value of x and y, variance of x and y. We have approximated this x to be following normal mu1 sigma 1 square,
okay,
and y to follow normal mu2 sigma 2 square.
Okay, thank you.
Yeah. So yeah, in this particular case, we are actually using again the normal. So we are converting this to standard normal. So what we do? We divide t by sigma t. This will follow standard normal 0, 1. Correct?
Okay.
Now as we are using again the z distribution, the standard normal distribution. So even this is named as z test for two samples.
Everything which we did in z test, same we do.
Yeah, same we do. But here we compare, there we test for mean, and here we are comparing means.
Comparing this.
And the final, just now we have discussed this. So two samples you have, and we are testing to compare variances. So if you are comparing variances, and your test statistic will be sx square by sy square, and you reject h naught if t is greater than 1 plus cr, and or you reject h naught when t is less than 1 minus cl. So for this setting, so in order to compute alpha, if we have given h naught is true, then this particular sx square by sy square follows f distribution. So if ha is true, then t times sigma 2 square sigma 1 square follow f distribution. This is what you have to understand. So if ha is true, you should multiply sigma 2 square by sigma 1 square, because sigma 1 is not equal to sigma 2 when ha is true.
What
Sigma
kind
1,
of sorry, no problem, sir. Continue.
Yeah. So this particular setting we use the very new distribution f test. So we use f distribution. So this particular test is named as f test. So we are using f distribution to compute the probabilities.
Sir?
Okay. So these are the standard tests. Yeah.
What kind of distribution these are? Like we talk about chi, t, f, right? Like when we started learning, we learned about two kinds of distribution: discrete distribution and continuous, right?
Yeah.
And then we classified certain distribution as discrete and certain as continuous. So under which category these fall? Continuous or discrete?
Continuous. See this t distribution, f distribution,
and chi-square.
And chi-square distribution all are continuous.
But I think in some cases chi-square has also been used for discrete also. I don't know whether that part is covered in additional lecture or what, but professor has covered that. I think when he's talking about ratio of something like likelihood ratio test. Sir, your screen has gone. I think that WordPad is not visible.
I just came to here.
Yeah. Okay. Sorry. Yeah. So these are, you are saying that these are continuous distribution only, right? So generally, in case of other distributions, we have studied their mean, their variance, everything. So are they applicable for these distributions also? Or something are looking very magical kind of thing. Okay, problem solving is one part. We are able to match answers up to 4 digits. There were many questions to match answers up to 4 digits. What do these actually signify?
See, you are asking me that chi-square
T and that F distribution, right?
Okay, T and F distribution. See, that is what I said. T distribution is very much students design distribution is what I think. That student T test, what we say is, if you are not that confident that Z table actually approximates the probabilities, what they did is they have designed separate tables by considering the sample variances, not the distribution variance. Considering the sample variance itself, they computed the probabilities or the significance levels, everything.
So we'll study about mean, variance, everything about these distributions also.
No. See, I just opened chi-square, right? You see the PDF of chi-square.
Complex. CDF is also complex.
But mean is somewhat easily identifiable. So if I have 7 degrees of freedom, mean is actually 7.
Actually 7.
Okay. Variance is
2 times.
2 times of k. But we are not going to study about these things. Okay.
We just want to test.
For this, you need to understand this chi-square distribution, PDF of chi-square distribution. Then you can actually compute expectation of by integrating this PDF x times this integration. Ultimately,
so all of them are continuous continuous distribution.
Continuous distributions. You said chi-square is a continuous distribution. By looking at the PDF itself, you can.
Yeah, PDF is.
It's not discrete. It's actually continuous.
But I think chi-square is also for goodness of fit, because professor has also talked a little bit about goodness of fit in week 12 itself. Where he's talking about different grades, like and different number of students which got different grades. And then he was fitting that distribution.
That is an extra lecture.
Additional, right? Yeah, right.
Lecture. So we thought that is like bouncer for many of
you. True, sir.
So that is why we pushed that to additional lectures.
Thank you, sir.
So if you are interested, you can go through that.
But that's not a
you are pretty much enough with whatever the content you learn, you can stop right there.
Goodness of it is not under this.
Under our part of
syllabus
testing, part of the syllabus.
Sir, I have 2 questions, sir. Sir, one is, sir, in this course, is edifier test related to the time series? It is covered or it will separate?
Which one?
Sir, edifier test.
I haven't come across anything in this particular course.
Okay, sir. And sir, okay, sir. And sir, actually, sir, edifier test related to time series problem.
No.
Seasonality, to check the seasonality.
No.
Okay. And sir, one more thing, sir. I want to ask related to the course, sir. Sir, actually, sir, because of office and all the things, sir, I just forgot to give the this extra activity, 9 or 6, that one. Sir, I forgot to give the peer review, but I submitted the assignment, but I forgot due to workload and all the things. Sir, I saw tomorrow. Sorry, today morning, and I said, shit. So, sir, will I get 0 or is there anything? Because previously I gave the peer review, but the last one I forgot.
So can you just post this in Discourse? I'm not that aware of this extra activity thing happening. Okay.
Okay.
If you I haven't seen this. I'm not included in that extra activity. Yeah.
Okay.
That's not maybe my part, my job.
Okay.
You just post a discourse post. Maybe Mayur, you can tag the instructor Mayur.
Okay.
And ask.
Okay.
So you can ask. So chi-square, yeah, whatever the distribution we dealt, those all are, you can see, you can play with this. What I suggest you is, if you got time, just search for this kind of sites, online sites, and understand the distributions clearly. So that will give you more idea. Okay.
True.
Okay.
Time we don't have.
Time we don't have.
If we don't have time, then
time is less.
Can you ping that this one's a link, sir? Just join.
What?
That link, sir. The link where you have the distributions, right?
Okay.
Can you ping it?
That is stat. I am just typing
in chat.
Yeah.
I have a question which is a little off of the topic, but related essentially.
So just give me 1 minute, okay? Just give me
Sure.
Everyone understood F distribution and what are the different types of distributions we have? And
yes, sir.
Clear about right? So those who are done, you can take break. Okay, we are done for today.
Okay.
And maybe you have one more session, right?
Sir, keep your notepad active, sir. Keep your notepad active, sir.
Acha, why?
As I, sir, I know you will stop recording, but keep your notepad active at least, sir.
Okay.
Last time we struggled because of that, because your notepad was not active. Okay, now you can stop recording, no problem.
Yeah.
If you are done with the session, then. Actually, I missed this session, sir. I had some meeting. So
you have what?
Actually, I missed this session completely.
Oh, actually, just watch it in the YouTube.
Yeah. I just want to check. So it will be there for about a week or so.
Yeah, not week.
A lifetime. It will
be there.
Okay.
Even after endum also you have. Even we have term 1.
Yeah, it remains there, sir. It remains there. It remains there. Even earlier videos.
These all are getting stored in YouTube channel, right?
Yes.
Sir, we have only 3 sessions for revision now in the stats for the end term.
Yeah, we have 3 sessions. One is from week 1 to 6. Another is mock session, and another is 7 to 12.
7 to 12. Okay.
Okay.
Like descriptive statistics one part and distributions other part.
Okay.
So most
and
of
yes. And so the end term, it is 70 and 30 na? 9 to 12 70 and 1 to 8 30.
Weightage has been given, right?
Yeah, it is given, and on the mail.
So that is how it will be.
Okay.
So if you understand the descriptive statistics very well, then you will get a decent, good score.
Okay.
You can.
The descriptive, you mean? I mean, I think it's given 9 to 12, 70%, right? Weightage 9 to 12.